Explosive discharge, barbecue it! We're just cooking some lunch. Do you want to see what's in the barbecue, Chris? Oh. We're on the lowest heat setting, but, you know, sausages are cooked on the outside and not on the inside. But personally, from what I can remember, pork is fine to eat raw. Let's do something stupid! We're going to get blown up. What are you going to attempt to do?
I'm going to try and cut through this.
Oh no, unable to charge, it's fine.
Oh shit!
the tent peg has melted in half completely. We're using the original supply.
Fixed it!
I think we're our own worst enemy here. Yes!
Damn it!
That is, well, that's fully on there as well. That's 2, 3. Within 3 seconds, it's molten. 1, 2. 2 seconds and it's molten. Just goes away. Time for a lovely cherry bake one, I think, Chris. Eat the cherry. Num num. Oh, what the fuck?
Mr. Kipling,
Oh, it's burned.
I wanted to eat that as well.
It's still good. I'll eat some bits off the top.
Oh.
Oh. Just going to make sure it's all earthed correctly.
Mate, honestly, you don't want to. The cable jumps. When you saw it from the magnetic field, the blue cable jumps up in the air. Bought this smoke alarm. It's good quality. This is made by
It's on the front.
Smoke Alarm.
It's actually what it says on it.
EI Home. This is made by. Ooh. And usually when you press your smoke alarm test button, you get a nice beep noise. You have to hold it for quite a long time. This is our 16 gig memory stick from play.com.
Well, we've got plenty of smoke. Couldn't be travelling into the smoke alarm anymore. Nice. That should be. Although there's paper this side, which is probably going to set it off. Sorry, but this is ridiculous.
I do not want this in my house any longer. It's probably dangerous.
Yay!
Please get a close up of this. Right, what we've done is we've made an LED using a memory stick and tomato sauce. You ready?
Help! I don't understand. The closer. Do it somewhere else completely, do it over here. What? Oh my.
Hi guys, we've made something educational for a change.
We are proud of ourselves.
It's accurate, fairly accurate. Now, if you've sort of messed about with high current things before, you'll know you can buy normal ammeters. I haven't got one to hand. Normal multimeters can usually measure about 10 amps. Pushing it, you can get 15 amps out of them, and they usually go horribly wrong. But you can get higher amp ones that will do sort of 600 amps, and they work using a thing called a shunt, which is basically a big resistor. And you put all your current through this resistor, so you'd have your battery there and your load there, all the current through the resistor, and you would measure the voltage drop across that resistor. And obviously the voltage drop is going to be proportionate to the amount of current you're putting through it, and you'll get a reading. And then you can use a formula, or some digital ones will automatically tell you the current you're getting. So what we've made is a DIY version of this, very cheap, from just bits we had laying about.
Just a bit of earth cable.
And we've used an Excel spreadsheet, so we're going to use the resistivity of copper, because we're using copper wire, the length of our shunt, which is 2 meters of copper wire, and then we've just used this to work out.
Yeah, there's the width of each core, plus how many cores.
The 7-core cable, 1.45 millimeters per core. That's 10.15 mil. It's supposed to be 10 mil cable, but we'll go over it. That then changes to square meters for the area, and then all of this uses the resistivity formula to work out the resistance of our bit of cable. and then we can put in our measured drop in millivolts from our voltmeter, which will give us a current.
So we'll give it a try. We have got we thought, what's inefficient and shit? So we found this inverter, and we're going to run a 100 watt light bulb off it. Right, what we're going to do is we're going to power up the inverter with the 100 watt light bulb in the holster. There you go. And as you can see on our multimeter, which is in, is this millivolts mode?
Yeah, that's millivolts.
Yeah, that's set to 200M. We're getting 30.9, sorry. And that's simply connected up. Our physical shunt itself is this bit of earth cable, which is 10 mil square. According to it, we actually figured it out at 10.15. 10.15, I think. So we've got one end of the multimeter there, and the other connected in with the actual inverter itself. It's warm.
Really?
Yes.
Christ, we should probably kill this now.
Yeah.
So
That is 9 amps.
Your shunt goes in series with the load, and then the voltmeter goes in parallel with the shunt. And I'll put a circuit diagram
Right there.
right there. I'm going to try and superimpose it using Windows Movie Maker, and it will be terrible.
We're also going to have a sheep there on that Mingles tin. You won't even be able to see that it's a Mingles tin, to be honest with you. I hope.
I don't think we can do this in movie player.
It'll be fine. Right, so we're going to enter our values, which was 30.9 millivolts. And it's worked out our current to be
9 amps.
over 9 amps, yeah, which is about right if we do some simple maths. 100 watt light bulb, inefficiencies of the inverter.
Probably about 90%. 100 watts divided by 12 is 8 amps. There we go.
Time lapse over. There you go, 8.3 amps plus all the
Inefficiencies of the inverter.
plus the cable that we're getting quite warm. Obviously that's adding a bit more resistance to the whole situation.
There you go. That's all.
That's pretty much.
I've compensated for inefficiency a bit too much.
Pretty much bang on. But this just means we can measure how many amps we're pulling when we do stupid things. Right, I'm going to have a go at the technical side of things here. Chris is the physics man usually. Anyway, we've got this multimeter rigged up for a bit of calibration. We've got the 40 watt light bulb in, and this is going to read direct amps. It's on amp mode, and the reason we don't usually do this is because this is limited to 10 amps, which is why we've made the shunt in the first place. This multimeter over here is reading in millivolts, the drop across the shunt, so that we can put it into our calculator and figure out what's going on. So when we turn the inverter on, it will beep solidly, because this multimeter causes a voltage drop, which makes the inverter think that the batteries are low on voltage, so it turns off after about 3 seconds. But you will get a reading on there. So, ready? So we got 3.7 on there.
Yeah, 3.7, 3.8.
Do you want to give it another go, just for argument's sake?
Yeah, go on. 3.8.
3.8 I saw on there. And
then we'll just do it again for this.
doing it one more time on here. Sorry about the annoying beep. We've got...
That's not helps. Turn that off.
I can't.
Time out.
And we got 14.1 I saw on 14.3.
Yeah, run that again, just for argument's sake.
14.2, pretty much. So we can go over to our calculator and we can shove 14, that's gone very wrong, hasn't it?
Escape.
14.1 or
Yeah,
just 14?
14.
Which reckons it's 4 amps.
And what was it? I can't remember already.
I really can't remember either.
Let's go and try
It
again.
was 3.7, it was 3.8 we got on there actually, if I remember
So we
rightly.
just worked out as 4, and it's
So
actually 3.8, which
we're
is
0.2 out, which when we do more calculations we can get to a stage where our calculator can get more complicated, and we can actually work out a little scale that will try and compensate for the...
I can't be bothered. This is
No,
accurate enough.
neither can I. But when we start doing some high amp stuff, we can see what the drop is there, even though we can't measure it with another thing. This is going to give us a ballpark. Just having a quick look at the UPS. Oh no, it's not. It's connected to all of that electronic equipment over there. Anyway, we're doing a little shunt test. Actually, is what we're doing here. So we've got our shunt connected around there with the voltmeter on 2 volt mode, because we think we're going to pull about 20 amps. I would have thought.
We'll find out.
We'll find out exactly. So we're going to run, first of all, we're going to crank the fan on.
Oh, we might as well just do the lights first.
Okay.
Okay, turn the inverter on. And that's a 100-watt light bulb, and we've got...
Right, 100-watt light bulbs on over there. And we're putting 0.031, so that's 31 millivolts, isn't it? And we'll drop there, yeah.
And we'll turn 60, 40 on that was.
So we've got another 40-watt light bulb in there.
And a 60-watt light bulb.
Oops, sorry, we've got some glare. We've got a 60-watt light bulb in there now.
Fans just come on.
Yep.
And I'll turn this fan on.
And we've now got... That fan should... Is that on highest mode? Right. So we've got 87 millivolts. So if we go over to our calculator for now... Oh, Chris, mate, my laptop needs charging. Can you plug it in? Plugging a laptop charger in, we got just under 100 millivolts. So we've got we've actually increased to. It's fluctuating a lot.
115. That tops out.
Everything's buzzing a little bit, but we're on about 110. So if we go over to our spreadsheet, what should we crank in millivolts?
110. I'm going to just switch this down to 200M mode.
What are we on at the moment?
110-ish, yeah.
So, 110 in there, 32.1 amps we're pulling.
It's not a lot, is it? Shared across those batteries is fine.
Shared across the batteries is nothing. And we're just about to plug this Dimplex panel heater in, which is lovely. So, you ready? We plugged in? Yep. So we're instantly up to over what we were by running all of that equipment. We had 3 lights running, a fan and my laptop, and we're
111.
already over.
So,
So, as we can see from here, 111 is about 32 amps, which is what's being pulled at the moment.
150 watts.
Yep, we're pulling.
The fan went down then, can't you?
We're now pulling 143.5 milliwatts.
Add another 60.
Yeah, we'll see what we can crank it up to. 158.
Okay, this is going to be 600 watts. This will be the limit of the inverter.
We'll see. That didn't add much really. We're on 175. 174, sorry. Exactly 174. So, just for argument's sake, pop it in here and see theoretically how many amps we're pulling. I can't spell. There we go. So, apparently, it's just about 50 amps. That seems like an awful lot. Can we do something to check this? So we've got 600 divided by 50. Fucking hell, yeah.
That's quite close, isn't it?
So you can see from that our very simple bit of maths and physics, cheapo voltmeter. You could do it with any voltmeter, couldn't you?
Yeah. To be honest, you could, if you went out and bought this setup, that cable was.
The cable was £2 or something.
£2 or £3, and the voltmeter was 15.
Yeah.
But you can get anyone on offer. You can probably get all of this on eBay sorted for a £5, couldn't you? They'll be crap.
Well, yeah, I mean a voltmeter on its own, you can get a millivoltmeter for a couple of quid delivered.
Well, that's true. You can get the little millivolt ones.
Just the panel ones, yeah. Right.